Okay guys, let's talk about the questions on vector algebra. Given that x minus a cap dot x vector plus a cap is 8. So this is given to me, x vector minus a cap dot product x vector plus a cap. This is 8. That means what is it? X vector dot x vector is mod of x vector whole square plus x vector dot a cap minus a cap dot x vector, or x vector dot a cap is the same thing, minus mod of a cap whole square. What is this? X dot x plus x dot a minus a dot x minus a dot a. This is 8. Obviously this is 0. This is mod of x vector whole square. This is a unit vector, you can see it is a cap, so this is 1. You basically get 8 plus 1, that is 9, and so mod of x vector turns out to be 3. Fine. X dot a is given to be 2. Angle between x minus a and x plus a is being asked. Talking about x minus a and x plus a. Now talk about x minus a dot x minus a. What is this? Mod of x minus a whole square. This is actually a cap because it's a unit vector. Now what is this? X dot x, mod x whole square minus x dot a minus x dot a, again minus x dot a, then you have plus this square equals magnitude of x minus a square. Now mod x we just found it was 3, so this is 9, minus x dot a is given to be 2. So minus 2 gives you minus 4, plus this is 1. This is 5 plus 1, 6. So you are basically getting that root 6 is equal to mod of x minus a. Mod of x minus a is coming out to be root 6. So exactly in a similar fashion, when you perform x plus a dot x plus a, you get mod of x plus a whole square, and that comes out to be 14. So mod of x plus a comes out to be root 14. The moment you have got mod of x minus a and mod of x plus a, how is that going to help us to get the angle between x minus a and x plus a? That is going to help us because x minus a dot x plus a is equal to, so this is again a cap, mod of x minus a mod of x plus a cos theta, where theta is the angle between these two vectors, x minus a and x plus a. This is already given in the question as 8. Mod of x minus a you found as root 6. This you found as root 14 cos theta. And thus cos theta comes out to be 4 by root 21. If cos theta is this, sec theta is 1 by cos theta, which is root 21 by 4, isn't it? The moment you get this, you basically see that if sec theta is root 21 by 4, because cos theta is 4 by root 21, theta is sec inverse of root 21 by 4, and therefore A is the correct option. Moving to the next question, we have this vector is perpendicular to this vector and the other vector is perpendicular to this other vector. What is the angle between A and B? Let's talk about this now. So you know that when two vectors are perpendicular to each other, their dot product is 0, right? So first of all you get A vector plus 3 times B vector, its dot product with 7 times A vector minus 5 times B vector is 0. So you get A dot 7 times A, that means 7 times mod A square minus 5 times A dot B plus 21 times A dot B, or B dot A is the same thing, minus 15 b dot b, which is mod b square. So you get 7 times mod a square, then this is 21 minus 5, which is 16, a dot b, minus 15 mod b square. This is the first equation. It is also given that a minus 4b, so next you have a minus 4b is perpendicular to 7a minus 2b. So their dot product is again 0. A dot 7a is 7 times again mod a square minus 2 times a dot b minus 28 times a dot b plus 8 mod b square minus 4b dot minus 2b, which is 8 times mod b square. So this becomes 7 times mod a square minus 30 times a dot b plus 8 times mod b square is 0. This is the second one. When you subtract, what do you get? Here, let me write it here. This is 7 mod a square minus 30 a dot b plus 8 mod b square is 0. So when you subtract, basically, what do you obtain is this cancels out. You have 30 minus 16, which is 14 a dot b. Okay. Then this is what? This is minus of 23 mod b square equals 0. Right? What did you get from here? You got 7 mod a square minus 5 a dot b plus 21 a dot b minus 15 mod b square. So 21 minus 5 gave you plus 16. This is plus 16, and therefore 30 plus 16 actually gives you 46. Now that you've got this, you basically get that 46 a dot b equals 23 mod b square. So what do you get from here is, because 23 into 2 is 46, you get a dot b is mod b square by 2. If a dot b is this, but you also know that a dot b is mod a mod b cos theta, that means mod b square by 2, because a dot b is mod b square by 2, equals, now mod a, what is given in the question is that this is perpendicular to this and this is perpendicular to this. Now it is asking what is the angle between a vector and b vector. Now over here, if I talk about a dot b, this has already come out to be mod b square upon 2, and this is mod a mod b cos theta. Right? Now what is mod a, mod b and cos theta? That is going to be given by what? Now this is a dot b is 23 mod b square, 46 a dot b is 23 mod b square, and you have this relation. These two relations are there basically to give you the entire hint as to how basically you are going to move ahead with computation of theta. So give it a thought and try to get the value of theta, and then we are going to move ahead with the next question. So guys, could you get the value of theta from here? See, this relation actually gave you that a dot b is mod b square by 2. If you put it in equation 1, what do you get? 7 mod a square plus 16 a dot b minus 15 mod b square equals 0. A dot b will be replaced by mod b square by 2, so you will be getting 8 mod b square minus 15 mod b square, which is minus 7 mod b square. 7 mod a square minus 7 mod a square, 7 mod a square minus 7 mod b square is 0. So you get mod a square equals mod b square, which means mod a equals mod b. The moment you get mod a equals mod b, this again becomes mod b square cos theta, because mod a is replaced by mod b. Now mod b square gets cancelled, and you are left with cos theta is 1 by 2 or theta is 60 degrees. So theta turns out to be nothing but 60. Next we have what question? Let's see. ABC are mutually perpendicular vectors of equal magnitude. Now the fact this itself line is giving us two observations. What are they? The first observation is that they are of equal magnitude, and second is that A dot B equals B dot C equals C dot A equals 0 because they are mutually perpendicular. What is the angle between A plus B plus C and A? Now see. What is this? This is mod A square plus mod B square plus mod C square, then plus 2 A dot B plus 2 B dot C plus 2 C dot A. But all that is 0, so plus 0. This is what? Mod A equals mod B equals mod C. So this becomes 3 times mod A square. Or you can say mod of A plus B plus C is equal to root 3 times mod A. I want the angle between A plus B plus C and A vector. What will that be? For that I am interested in the dot product. A dot A plus B plus C is equal to magnitude of A plus B plus C cos theta. A dot A is this, plus A dot B is 0, A dot C is 0, so that is it. What is magnitude of A plus B plus C? It is root 3 times magnitude of A. Magnitude of A, this is root 3 times magnitude of A. So you have magnitude of A whole square root 3 cos theta, and therefore you get cos theta is 1 by root 3, or theta is cos inverse 1 by root 3. Moving to the next question, we have if magnitude of A dot B is equal to magnitude of A cross B. Okay, so what is the question trying to give you? Magnitude of A dot B means magnitude of A, magnitude of B cos theta. This is equal to magnitude of A, magnitude of B sin theta n cap. So from here you get magnitude of A, magnitude of B, magnitude of cos theta equals magnitude of A, magnitude of B, magnitude of sin theta into magnitude of n cap, which is 1, it's a unit vector. Now obviously this means mod of cos theta equals mod of sin theta. Angle between A and B means what is theta? If mod of cos theta equals mod of sin theta, theta can assume either 45 or 135. Only these two values. It is for these two values that mod of cos theta equals mod of sin theta among the options. Okay. Moving to the next question, we have if a vector is of magnitude 3 root 6 and is directed along the bisector of the angle between these two vectors, then what is the actual value of this r vector? Now this is pretty nice to understand that r vector will be equal to lambda times A cap plus B cap. What is A cap? Unit vector in the direction of A vector. So it is 7i cap minus 4j cap minus 4k cap whole upon 7 square plus 4 square plus 4 square, which is root 81, which is 9. So you basically get 7 upon 9 I cap minus 4 upon 9 j cap minus 4 upon 9 k cap plus, this is B vector. What is magnitude of B vector? Under root of 2 square plus 1 square plus 2 square, which is under root 9, that is 3. And magnitude of A vector we just found was under root 81, which is 9. So here you have 3 with you. B cap will be minus 2 by 3 I cap minus j cap by 3 and plus 2 by 3 k cap. Now you have 7 by 9 minus 2 by 3. See, 7 by 9 minus 2 by 3 will be 7 minus 6. Why? 3 into 3 is 9, 2 into 3 is 6. So 7 minus 6 upon 9, which is 1 upon 9. Minus, then you have, or let me write it as plus minus 4 upon 9, and here it is plus minus 1 upon 3. So you have minus 4 upon 9 minus 1 upon 3, which is minus 4 minus 3 minus 7 upon 9. So you get plus 7 upon 9 j cap. And then you have minus 4 upon 9 plus 2 upon 3, which is minus 4 plus 6. 6 minus 4 is 2. So you get 2 upon 9 k cap. Okay. So now that you've got this, you basically have lambda by 9 I cap plus 7 j cap plus 2 k cap. Okay. Now, R vector you've got in terms of lambda, you actually want the correct value of R vector. It's given that magnitude of R vector is 3 root 6. So, magnitude of R vector whole square will be 3 root 6 whole square, which is 54. But actually magnitude of R vector will be magnitude of this thing whole square, which is lambda square by 81 into 1 square plus 7 square plus 2 square, which is again 54. So you get lambda square is 81, lambda is plus minus 9. So one vector will be I cap, because lambda will be 9, 9 upon 9 is 1. So one value of R vector, possible value is I cap plus 7 j cap plus 2 k cap, I cap plus 7 j cap plus 2 k cap, here it's not there. Or here second will be minus 9 upon 9, which is minus I cap minus 7 j cap minus 2 k cap. See over here, let's just look at one correction. This is 7 by 9 minus 4 by 9 and minus 4 by 9 again. Here it is minus 2 by 3, minus 1 by 3 and 2 by 3. When I am talking about taking just 9 out common, or if I do not take out 9 common, what basically I am left with is 7 by 9 minus 2 by 3 I cap plus minus 4 by 9, see, minus 4 by 9 minus 1 by 3 j cap plus minus 4 by 9 plus 2 by 3 k cap. Right? And that's what we did. What we did was 7 minus 6 was 1. So you got 1 by 9 I cap. After that you had minus 4 minus 3, that is minus 7. So this was minus 7 actually. Minus 7 by 9 j cap. And here it was minus 4 plus 6, that is 2 by 9 k cap. The moment you get this, nothing is going to change in here, but R vector will actually going to come out to be I cap minus 7 j cap plus 2 k cap and minus I cap plus 7 j cap minus 2 k cap. Depending upon lambda is 9 or minus 9, and hence lambda upon 9 is 1 or minus 1. Moving to the next question, we have ABC are three non-coplanar vectors such that R1 is given to you, R2 is given to you, R3 is given to you and R is given to you. And R's structure is given to you in terms of R1, R2, R3. Non-coplanarity implies linear independence. Fine. The only linear combination which is equal to 0 is the trivial linear combination. That means the scalars have to be 0. Here it is saying R vector, which is 2 times A vector minus 3 times B vector plus 4 times C vector is equal to lambda 1 times R1 vector. So let's see. Let's take out just A vector common. Then I have lambda 1 minus lambda 2 plus lambda 3 plus B vector common. According to this I am working. If B vector is coming out common, I get minus lambda 1 plus lambda 2 plus lambda 3. plus C vector, and then I'm going to have lambda 1 plus lambda 2 plus lambda 3. Now see, over here you can just say that R vector equals to this vector. So I can say 2 minus this expression times A vector plus minus 3 minus this expression times B vector plus 4 minus this much times C vector equals 0. But R1, R2, R3 are given to be non-coplanar. It's given to you. So their linear combination is coming out to be 0. That means the scalars have to be compulsorily 0. It is going to imply linear independence. And therefore, this is going to come out to be equal to 2. This will come out to be equal to minus 3. And this will come out to be equal to 4. What do you get? Lambda 1 minus lambda 2 plus lambda 3 is 2. Minus lambda 1 plus lambda 2 plus lambda 3 is minus 3. And lambda 1 plus lambda 2 plus lambda 3 is 4. When I talk about first two equations, lambda 1 minus lambda 2 plus lambda 3 is 2. So that's what you have. And then you have minus lambda 1 plus lambda 2 plus lambda 3 is minus 3. When you add, you basically get twice of lambda 3 equals minus 1. Lambda 3 is minus 1 by 2. When you substitute lambda 3 in the first equation, you get lambda 1 minus lambda 2, 2 plus 1 by 2, which is 5 by 2. And when here you substitute minus 1 by 2, it is 4 plus 1 by 2, which is again 9 by 2. So you get lambda 1 plus lambda 2 is 9 by 2. Now what you do is, basically this gets cancelled. You have minus 2 times lambda 2, 5 by 2 minus 9 by 2, which is minus 4 by 2, which is minus 2. And therefore lambda 2 comes out to be 1. What about lambda 1? Lambda 2 is 1, so lambda 1 is 5 by 2 plus 1, which is 7 by 2. So lambda 3 is minus 1 by 2, lambda 2 is 1, lambda 1 is 7 by 2. Option is lambda 1 is 7, that is wrong. Lambda 1 plus lambda 3. Lambda 1 is minus 1 by 2. Lambda 3 is minus 1 by 2 and lambda 1 is 7 by 2. 7 by 2 minus 1 by 2 is 6 by 2, which is 3. So yes, this is true. In fact, this is also true and this is not true. Moving to the next question, what is it that we have? Let's see. The volume of the parallelopiped whose edges are represented by A, B and C vector is what? So what is the volume? How do you measure the volume of this parallelopipe whose adjacent basically sides are given to you, edges are given to you? It is nothing but it's completely concept based. It is just scalar triple product of the three vectors, which is A dot B cross C. What is B cross C? I cap, J cap, K cap. B is what? 1, 2, minus 1. And C is what? 3 minus 1, 2. Just find out this vector. What is this? It is I cap 4 minus 1, that is 3, minus J cap 2 plus 3, that is 5, 2 plus 3, 5, plus K cap minus 1 minus 6 minus 7. So option is actually giving you one point that B cross C is 3I cap minus 5J cap minus 7K cap, and this is the correct option. Now what is A vector? A vector is 2I cap minus 3J cap plus 4K cap dot product with 3I cap minus 5J cap minus 7K cap. So you get 2 into 3, which is 6, plus 15 minus 28. So this becomes 21 minus 28, which is minus 7. So your answer is not 7 cubic units, but actually A dot B cross C is minus 7, or ABC scalar triple product is minus 7. The volume comes out to be minus 7 cubic units. Next question, let's see, is what? An expression is given to you and you are being asked what is it equal to. Okay, let's try to understand. All the properties should be at our fingertips. A plus 2B minus C, right? Dot product with. Now here, something cross something. Use the distributive property. Addition and subtraction, they are distributive over the cross product. This is A cross A. A cross A minus A cross B minus A cross C minus B cross A plus B cross B and then plus B cross C. Clearly this is 0, this is 0, right? Minus A cross B and minus B cross A. Minus B cross A is nothing but this is plus A cross B, because A cross B is same as minus of B cross A, and therefore this and this they get cancelled out. So you are just left with B cross C minus A cross C or plus C cross A. And you have this in the dot product, A plus 2B minus C. And therefore, because dot product is distributive over addition, I get A plus 2B minus C. Dot product with B cross C. That means scalar triple product of this B and C plus exactly in a similar fashion this dot product with C cross A means this and then C and then A scalar triple product. Clear? And now comes the time to apply the properties of scalar triple product. What do they say? A, B, C, scalar triple product of A, B, C plus scalar triple product of 2B, B, C, 2B, B, C minus scalar triple product of C, B, C. Come here. Scalar triple product of ACA plus twice or plus scalar triple product of twice of B, C, A minus scalar triple product of C, C, A. You know that this 2 can come out, this 2 can come out. Just simply using the properties of scalar triple product. Now here, because these two are same, this is going to be 0. Here these two are same, this is going to be 0. Here this is going to be 0, this is going to be 0. So what are you getting is ABC plus twice of BCA. A, B, C plus twice of BCA. BCA can be written as, you can swap these two and then swap the rest of the two. What I'm trying to say is, over here, I'm just trying to say that BCA scalar triple product is same as minus of A, C, B. Just swap these two. A negative sign is going to come into picture. And now you swap these two. So again, minus of minus is going to make it plus. This is what I'm trying to say. That ABC is same as BCA. So BCA is same as ABC. So I can write this as again ABC scalar triple product. 1 times plus 2 times gives you 3 times ABC scalar triple product, or 3 times A dot B cross C but ABC is same as BCA, so 3 times this, and this is obviously wrong. Talking about the next question, we have that the unit vector which is orthogonal to this vector, this given vector, and is coplanar with this vector and this vector is which vector? Okay, so I don't need to find the vector, I actually need to find such a unit vector. We already know what is this vector. This vector is nothing but A cross B cross C. Just a direct conceptual approach. Vector triple product of A, B and C, which is A dot C times B minus A dot B times C. What is A dot C? So this is your A and this is your C. So you get 3 into 1, which is 3, plus 2 into 1, which is 2, plus 6 into 1, which is 6, times B vector, which is 2i cap plus j cap plus k cap. Fine. Minus, this is A dot C. Okay, so here it was A dot C. 3 into 1 plus 2 into 1 plus 6 into 1. Then you have minus A dot B. A dot B, so you do 3 into 2 is 6, plus 2 into 1 is 2, plus 6 into 1 is 6, times C vector I cap plus j cap plus k cap. You are getting 11 2i cap plus j cap plus k cap minus 14 I cap plus j cap plus k cap. 11 into 2 is 22, right? 22 minus 14 gives you 8 I cap plus 11 minus 14 gives you minus 3 j cap plus again 11 minus 14 gives you minus 3 k cap, right? The moment you've got this, now it's very simple to get the unit vector. So quickly get the unit vector and then finish up this question, okay? So guys, in here there is a slight change. Here actually it is not plus but minus. Of course you can evaluate from here itself, but the question has minus, and therefore when I'm talking about A dot C times B, there is a change in A dot C. Here it will be minus 2 and not plus 2. So this is going to give you just a 7. Fine. So A dot C times B, that is this, minus A dot B times C, which is this. So you get what? Let's see. You actually get 14 minus 14, that is 0 I cap, 7 plus 14, that is 21 j cap, 7 minus 14, which is minus 7 k cap. So from here you can obviously take out 7 common and you get 3j cap minus k cap because it is 7 into 1, that is 7, plus 14 into 1, which is 21, then it is 7 into 1 minus 14 into 1, which is minus 7. The moment you get this, what is the unit vector? Unit vector will be 3i cap minus k cap into 7 whole upon under root of 7 square, 3 square plus 1 square. Now this is 7 square. When it comes out of the square root, it becomes 7. This gets cancelled. So you get 3 by root 10 I cap and 1 by root 10 k cap. So 3 by root 10, not I cap but j cap, because I cap has become 0. So you get 3 by root 10 j cap minus 3 by root 10 k cap, which is this, 3 by root 10 j cap minus 1 by root 10 k cap. It's also saying, is it equal to 3j cap minus k cap? No, because I am searching for the unit vector. Yes, it was 3j cap minus k cap in here, but that was also not the complete vector. 7 times 3j cap minus k cap was the complete vector, but that's not the complete answer, because I want the unit vector, which is only this. Moving to the next, we have Find a set of vectors reciprocal to A, B and A cross B. So let's take A, B and C, where C is A cross B, and find the reciprocal system of vectors. Say it is A dash, B dash and C dash. A dash will be B cross C upon scalar triple product of A, B, C. B cross C is B cross A cross B because C is this. Scalar triple product of A, B, C is nothing but A cross B dot C. Now this becomes what? A cross B dot C, but C is what? C is again A cross B. A cross B dot A cross B is mod of A cross B whole square. So you basically get B cross A cross B upon mod of A cross B whole square. This is the first vector in the system of reciprocal vectors. Exactly in a similar fashion, there will be B dash vector, which is C cross A upon again scalar triple product of A, B, C. C is what? A cross B. Cross A whole upon exact same procedure, end up over here, magnitude of A cross B whole square, and then there is C dash vector, which is A cross B upon scalar triple product of A, B, C, which is A cross B upon magnitude of A cross B square. So the solutions are B cross C upon A, B, C, yes. C cross A upon magnitude of A cross B square, yes. Then you have A cross B upon this, yes. A cross B cross C, no. Clear? That's how we deal with the problems on vectors. So spend good quality time with these questions. They're really important and nice. That's it from my side. Thank you.